applications of linear equations. All right, so the first thing you want to do when you're working on applications of linear equations is making sure that you recognize some keywords. So here I've gone ahead and made a table for you of some keywords to look for. So other ways of saying addition would be sum, more than, and total. Other ways of saying subtraction would be difference, less than, and minus. Multiplication can be written as product and times, and division can be written as quotient divided by or per. Now, is often translates into an equal sign when you're dealing with word problems. All right, so let's look at our first example. Now, our first example says 3 less than 4 times a number equals 17. Now, be very careful that you read the full instructions. Instructions say to write the sentence as an equation and let the variable x represent the number. All right, so I know that I'm going to have x representing the variable here. So we have 3 less than something. Well, we need to figure out what we're taking 3 away from. Right? It says 4 times a number, so that would indicate the 4x. Now the fact that we're doing 3 less than some number, so 3 less than, means I'm going to subtract 3. And then you're told that that equals 17. All right, so let's look at another example. Word problems, everyone's favorite, right? All right, so it says a rectangular carpet has a perimeter of 288 inches. The length of the carpet is 96 inches more than the width. What are the dimensions of the carpet? All right, so the first thing I want to do here is I want to go ahead and establish my variables. So I'm going to say that W is the width of the carpet in inches. I'm going to say that L is equal to the length in inches of the carpet. Now you're told that it's a rectangular carpet, and you're told that the length of the carpet is 96 inches more than the width. All right, so in other words, you're told that L, the length, is equal to 96 plus W. Now, because you know it's a rectangular carpet, sorry about that, you know that P is equal to 2 times the length plus 2 times the width. Now, P being your perimeter. So you know that the perimeter is equal to 288 inches. Now, right now you have L and W, so you have 2 variables. You want to make it so that you only have 1 variable. Now, because you're given your length in terms of width, so meaning the 96 plus W, you can replace the L here with the 96 plus W. So that would give me 2 times 96 plus W, because that's what you're told that length is equal to, plus 2W. So this gives me 288 is equal to 2 times 96, which is 192, plus 2w plus 2w. All right, at this point, I'm going to combine my like terms. So that will give me 288 is equal to 192 plus 4w. So now I'll subtract 192 from both sides. And that gives me 96 is equal to 4w. I'll divide both sides by 4. And that gives me w is equal to 24 inches. Now we are not done though, because you're asked for the dimensions of the carpet, meaning the length and the width. So what you're going to do now is you're going to plug in your value of w in here, where it says L is equal to 96 plus w, so 96 plus the 24. So your length is equal to 120 inches. Right, the next objective talked about in this section deals with simple interest. You'll note that for time purposes, we don't have an example here. If you need an example, go ahead and send me an email and I will add an example of this type of problem. There are already some in your lectures and resources folder as well. So if you have problems with this. What I want to point out, however, it's a fairly straightforward formula. So for simple interest, where I is equal to P times R times T, where P is your principal amount, R is your interest rate, and T is your time in years. Just be very careful that when you're doing your interest rate, you are giving this in decimal form. Very important that that is in decimal form. So meaning if it was 8%, so what that means, if you have 8% interest rate, you need to write that as 0.08 for R. All right, and let's look at our last word problem for this section. And that is a motion problem. So you've already dealt with motion problems from intermediate algebra, but we're going to go ahead and touch on them again in this class as well. All right, so you have a train that leaves Little Rock, Arkansas and travels north at 85 kilometers per hour. Another train leaves at the same time and travels south at 95 kilometers per hour. How long will it take before they are 315 kilometers apart? All right, so the first thing you want to do is establish your variable. So we're going to go ahead and say that x is equal to our time in hours. Now, for these types of problems, I like to do two things. I like to set up a table, and I also like to draw myself a picture because it helps me to visualize what exactly is happening. All right, so we've got one train that's going north, right? So we'll go ahead and say that this one is our north train. And then we've got our south train. I'm just setting up our table. You should always already know that distance is equal to rate times time. So you've got your rate, you've got your time, and you've got your distance for these. All right, so you're told that the north train, or the train traveling north, is going at 85 kilometers per hour, whereas the one going south is going at 95 kilometers per hour. And so x will be your time in hours. They left at the same time, which is why that variable is the same for both. Very important here is your x is given in terms of hours. Because they left at the same time, your time is the same. However, if one had left an hour before, then one of these would be x plus 1. If it was in terms of 15 minutes before, then it would be x plus 15 over 60, which obviously then you could simplify out to 1/4. All right, now your distance is equal to rate times time. So for the north train, that's 85x. For the south train, that's 95x. All right, so here's where we're going to draw ourselves a little picture to kind of help us visualize what exactly is happening. All right, so they are starting from the same point. Okay, so we're going to call this the starting point. Now, you've got one that's going south and one that is going north. Now, the southbound train will have traveled a total distance of 95x, whereas the northbound train will have traveled a total distance of 85x. Keep in mind where x is the time in hours, depending on how long that takes. And what we want to know is we want to know how long it'll take before the total distance between the southbound train and the northbound train will equal 315 kilometers. Now, if you look at the picture, hopefully it's a little bit straightforward that what it's saying is we want to know when 95x plus 85x will equal 315. So we combine our like terms. That gives me 180x equals 315. And then I divide both sides by 180. And that should give me x is equal to 1.75 hours.